Thanks, Paul. Thanks for inviting me back and welcome. Thanks to everybody who's taken the time this morning to join us. So as Paul said, my intention today is to talk a little bit about Single Node Openshift and the installation. I want to give credit to some colleagues, Daniel Casale, my peer in America, Federico created the HMC scanner and has created some Ansible scripts for this. And also Sylvain from Montpellier, client engineering, that's also looked at another way of installing it. There is a fourth way too, but there's only so much you can cut into 30 minutes. So I thought we'd first of all talk a little bit about Single Node Openshift, what it is and any limitations, that kind of stuff. Then I'll go through the first method of installing it, which is manual. So it's all documented by Red Hat. I went through that and created some scripts for it, and that was for the purpose of doing the Teach the Teacher event in Prague in April. So there are some recordings for that I need to edit before sharing on YouTube and LinkedIn, etc. But that's where that comes from. Then we can look at some Ansible playbooks for achieving the same end. And then a third way of doing it using Red Hat assisted installer. There is a fourth way that I'm aware of, and probably the most common way that I've heard over the last 4 or 5 years of people installing OpenShift, the helper node. I find that everybody prefers the one that they use, probably because it's more familiar to them, but sometimes, some of them want Power VC to be in place, sometimes some want DHCP, so it all depends which is the best fit for the environment that you're installing it to. And my experience is customer environments are always different. So Single Node Openshift, what is it? Well, it is really the same as a regular OpenShift implementation. It's just that where you'd normally have 3 control plane nodes and 2 or more worker nodes, it's all done in the same node. So we have one virtual machine, if you like, and that's doing all the control plane work and all the worker node stuff too. That does bring with it some limitations, but obviously it also means that you use a lot less resource for it. So in Italy, we have an awful lot of IBM and people run their entire companies on just one power server. I'm very pleased with the stability and the availability of that. They question why they need 3 or 5 different servers to run something like this. Perhaps with x86, it's not quite the same. They don't tend to last quite so long. There's more failures and stuff, which makes a lot more sense. But I guess when I started off working with OpenShift 4 or 5 years ago, people were always saying, what's the minimum you need? And when you start totting up, 8 virtual CPUs for 3 control planes and 2 or more worker nodes, and then you can get infrastructure nodes as well, it mounts up. But my answer to that is you really need to size it for the amount of workload that you're going to place on OpenShift rather than sizing for OpenShift itself. The official reply for Single Node OpenShift, at least now, is 8 virtual CPU cores, 16 gigabytes of memory, and 120 gig of storage. They're all what Red Hat would say the minimum. However, they do say that 1 vCPU is equivalent to the amount of threads per core by sockets, etc. So actually, if we're running power in SMT8 mode and we get 8 threads per physical core, that means that we can run Single Node OpenShift on 1 physical core. So an awful lot, if not most people would be able to find some spare capacity on their systems today to run OpenShift, I think. 16 gigabytes of memory, the minimum stated by Red Hat. The recommendation would be go for 24. That's also from Red Hat, and 32 is probably best. Today, we'll see later on, I just happen to have 64 gig. That's not because I need it for these environments. It's just because I've kind of gone to our cloud environment and said, give me some systems to run this. And I'm using two cores and 64 gig of memory. The storage obviously depends on how much you use. I think today we're probably only using about 20 gig of that 120 gig that's been allocated. But again, it really comes down to what applications and persistent volumes you're going to use for it. So just a few notes as I started investigating Single Node Openshift earlier in the year. Became available on x86 with version 4.9. It came into general availability for power in version 4.14, which was last November. We've already covered that it requires 8 virtual CPUs, which equates to 1 SMT8 processor core for power, and the memory and storage we've gone through already. Along with multi-arc compute that we talked about last week, questions come up is what about subscriptions, what about support, etc. So Single Node Openshift is part of regular Openshift subscriptions and support. There's no difference. You just pay per pair of cores that you're running Openshift on, so no change there. In terms of the length of time to carry out an installation, everybody that I'm aware of quotes sort of 45 minutes to 60 minutes. From my experience, you can normally access the cluster in about 30 minutes, maybe even from 20, and then it's continuing to stabilize and maybe further installations happening at that time. So allow at least an hour for the installation, but don't be surprised if you can access the system in half that amount of time. That did cause me some concern as I decided what to do today, really, because this is a 30-minute webinar, and I thought if I raced, we might just about be able to kick off an install and get there before the end, but 2 installations in half the amount of time that the recommendation to do it, I thought was too tight. So as Paul said, I kicked off 2 installations using 2 different methods. One at about 8:45 this morning, one at 9 o'clock this morning, or thereabouts. So the first stage of that, the installation has actually already gone through. And what I'll do, I'll go onto those screens, and hopefully I've not lost connection, but I'll scroll back so you can see what I did there, and then we can pick up and look at the cluster from that point. So during the installation process itself, it'll reboot several times, just the way a normal OpenShift cluster does. So I've actually been using Single Node Openshift, or running OpenShift on a single node, for maybe 2 to 3 years at least now. So it's always been technically possible, and I have set it up for ISVs and customers that wanted to do that. The difference was it wasn't technically supported by Red Hat. So when we say Single Node Openshift, that means it's full production support from OpenShift. The next slide, I think, talks a little bit about the use cases, and one of those is edge computing. And if you have lots of Single Node Openshift on the edge, then you've got to think about how you're actually going to manage those. So I just want to say that Single Node Openshift can be managed and is fully supported to be managed by Red Hat Advanced Cluster Manager as well. And that way, if you've got 100 edge clusters running on single nodes, then you can still access and manage them, govern them all by the Red Hat Advanced Cluster Manager. The installation procedure is pretty much the same. There's not much difference. There's in the configuration file where you specify how many worker nodes or how many control planes. They're obviously different. We tell it to use just the one worker node, but it's not like a different product. It's the same product. It's just all squeezed into one single node. Now, I only learned this yesterday, but actually Cloud Pak for Data version 5 has just been announced, GA, and that's actually come through certified for Single Node Openshift. So IBM is starting to certify Cloud Paks and containerized solutions like that for Single Node Openshift as well. Things to be aware of in a similar style of Oracle and the likes, it's not supported for production in a virtualized environment with VMware and soft hypervisors like that. It's bare metal only for x86. Power VM comes as a hard virtualization with Power, so we kind of consider that we're bare metal, but we have got the advantages of virtualization already, so that's absolutely fine on Power and Power VM. Because obviously we're running it in one virtual machine, there is no high availability there, so that's obviously a consideration when you think of single node OpenShift, although rather obvious. And as we were talking about last week, with multi-arc compute, when you can start putting ARM, Z, Power, x86 all in the same clusters, obviously when you've only got a single node, you've only got a single architecture. So you can't update it from a single node to a multi-node and to change things after the fact. So use cases, Red Hat are very big in telco. There have historically been a lot of power systems in retail, in kind of edge-like solutions. So single node OpenShift would allow you to modernize, retail solutions and use Red Hat Advanced Cluster Manager perhaps to manage them in stores and things like that, or warehouses. Development, developers can spin up a very small implementation of OpenShift. There are other ways of doing that too, but that's another use case. Demos, I said we've been using OpenShift on the single node within our tech zone environment at IBM I've been using it, I think, for 3 years now. So, I do hundreds of demos using single node OpenShift. Merlin, a development environment for IBM I. Again, a lot of customers have one IBM I or perhaps two. They don't need the three. So being able to have a fully production supported OpenShift environment on just the one box, and maybe even with just one core, could be very advantage to them. And also with education, it just makes it easy for almost anybody to spin up an environment of OpenShift and to learn more about it, trial new things. So moving on to the first way of installing it, I'll just talk about some of the scripts. So this came about because I was doing a teacher in Prague in April. So I went through the documented way of installing OpenShift. Let me just change the screen here. So this is the documentation for 4.14 that came out in November, installing OpenShift on a single node. We scroll down to the bottom, we've got installing single node with IBM Power. So we've got all the hardware environments, requirements. We talk about setting up the Bastion. And this is where the documentation falls short a little bit, I think, because they say, well, you've got to have the right DNS, DHCP, HTTP servers, TFTP to enable PXE boot, etc. So that's all specified as a requirement before you get into the real instructions. So that's why I create the scripts to get all that set up in place, and Federico's Ansible scripts does all that for us as well. But it does take us through the method of installing single node OpenShift with setting up Grub. We have to download the different image files and kernel files and client files, etc. Initran. So it does take us step by step. Here you can see the configuration where we say, actually, this is a major difference, where we say, normally you might have 3 replicas there as standard for master or control planes, but for a single node that's changed to 1. And there's also an option here for worker nodes, I think. And you do see in the configuration files I use for my scripts and also the Ansible stuff, you can see all this quite clearly. So it is all there. But I found it easier to put it into a script, and even better into an Ansible environment. So let's go back to the presentation. Great. Okay. So as with most of these things, I do share it on new GAs and on LinkedIn. So that was shared last November. We've been through the installation. If I go back, I can also show where we get some of the files that we pull down with the scripts, and also the pull secret as part of the installation. So here we go on the dependencies line, then we pull down the live kernel and rootfs, init RAM file system, etc. And also on the clients section, so we download the client so that we get the OC commands to do that. Back to the presentation. Oh, and the pull secret. You will need your own individual pull secret to add in. It comes up for you in your dashboard on the Red Hat site, and you can see what clusters you've got. So I will update this and share videos of the installation at different stages, but here's just a couple of screenshots of the scripts that I use, part of the installation process, and then obviously the end result of OpenShift being up. So the installation scripts that I use 4 scripts. The first one I label 1 to install. So this actually installs software for DHCP, TFTP, and HTTP. We configure that using 3 configuration files. We start those services, then we download the files needed from the Red Hat site. We download the client files, so we get the OC command for the command line interface, and then we set off the ignition. Then we need to go into SMS menus on the power system and tell it to network boot. And when we've done all this, that will network boot, and that's the stage, that's the script that I've run this morning prior to starting this demo. I should keep an eye on the time. The next stage is the post install, and then this just installs the client binary, so we get the OC commands, saving configuration files, and then finally we do a check of the installation status. We share the credentials and the URL to access the site and the password that we can do for that. So the installation scripts requires this information. We need network information, subnet, net mask, gateways, base domains, aliases. So all this needs to be set up in name service and stuff. And then I've got 3 config files: the DHCP config, the grub config, and the installation config. So although it looks like there's a lot here, if you look at just this, you could just fill in the right information there and copy it into the script files. And this is the configuration files itself. So what I've done is created a template and just put the sections that you need to update to make it nice and simple. So this is for the DHCP, and then we have the installation scripts, and then we have the sorry, that was for the grub scripts there, and then we have the installation scripts again here, the master, replica 1, etc. That's all going to stay the same, as well as the internal networking. So I've done this on some standard machines today through TechZone, and that has 2 processing units, 2 cores, 64 gig of memory for the master node, and 0.2 of a processor for the Bastion node that I'm doing the installation from, with 4 gig of memory. So that said, let me pull this up. So what I've done this morning, here's the 4 scripts that I've spoken about, and I've just run that through. So this is installing the DHCP server. That's installed, and then I install the TFTP server. That's installed. We set up grub for the network boot. We set up DHCP. So this is using the config files I mentioned earlier. And then we enable the installation as well, and those services that's required. I do it step by step to watch to make sure it's okay, but it can all run through in just a few seconds when that's happened. This is the pull secret required to download that information, and then the services are up and running. So that's the first script that's taken place. Now the next one is the post install. So this is where it's going to download and use the client configuration files. And I'm going to put it into the path, copy the kube config, which shows the URL and the password, and then I'll pull out that password and URL information from the third script. So now we can see here that we've got a status of ready, control plane, and the system's been up for 67 minutes. Now, note the roles, it's a control plane master and a worker all together. We can see that it's all stabilized and all the containers are working just fine there. This is where we get the password from. Finally, we get the console. So if I take that, pop that into our browser up here. It's not got a certificate set up, so I just tell it to go ahead. While that's happening, I'll just get the password. Okay, should be there shortly. So I log in as kubeadmin. Password that was given to us from the script. Log in. And this is our new cluster. Now, if we go back, we can look in the CPU resources that's been used. And it's only set to 30 minutes at the moment. So if we go back 2 hours, then we can see that the installation came online at 9:30. So I'm not sure if this is the one I kicked off at 8:45 or 9 o'clock, but you can see it took either 30 minutes or 45 minutes. I would suggest 30 minutes for that to come through. So that's the first method of installation. And now take a look at the Ansible scripts. So I've got the links in the presentation slides that Paul, if he's not already, will be sharing with you. So it's all stored in GitHub. It's very well documented. So it describes to you how to do the installation, what architecture is supported, what it's doing. Initially, you set up Ansible. You create an Ansible user and set up the right permissions, switch user to the Ansible guy. And then this actually has, but for my scripted version, I assume there's an LPAR already there, but the Ansible scripts can also use the playbooks to create the LPAR for you, and it can also delete it afterwards, but it doesn't have to. So you can use which sections that you like the best. Now for the installation, you have to figure out all the config data that I've shared on my scripted versions. They're all stored in YAML files, LPAR, HMC, network, and OCP within the vars direction. We could take a look at that if we've got time in a moment. But we're essentially doing the same thing. The pull secret is stored in the vars pull secret file, and the installation is kicked off by using the Ansible playbook install snow. Obviously, we're saying it takes about an hour. We've run that as well. You can either open the terminal via the HMC, or you can SSH in to watch the installation progress. The documentation, Federico's done a great job on this. Again, I'm using 2 cores for the master server with 64 gig of memory. You quite happily get away with a quarter of that or a half. For the Bastion, again, I think that's wrong actually. This is what I used in April, but 0.2 cores today along with the 64 gig. Now, if I stop that and bring across the putty session, here we go. So this is the Ansible. So I said that you use the Ansible playbook installation here, and it all tells you what it's doing. It connects, it sets up SSH keys. This actually goes to SMS and boots up to get the MAC addresses and stuff, and does all the LPAR boot automatically. Goes through, performs the installation, all nicely documented there with a little play recap at the back saying that there's no problems as such. So that's the installation that's taken place there. Again, I did that 8:45, 9 o'clock this morning. If we look in the bars file, then we can see where the configuration data has been stored for the LPAR or for the HMCs. Keeping an idea on time, we're getting a little bit short. So what I did, in addition to the Ansible scripts that you've got there, just last night or this morning, I just put a couple of commands there to figure out easily. All the data is there, you can put it out, but I thought it'd be easier just to run this, which gives us our console for that particular cluster. We bring the, so let's, we can start that. Just takes a little bit longer to log in for the first time. What's happening? I'll grab the password. Here's the password here. Okay, again, we log in as kubeadmin. That password provided to us. And we should be there in just a few seconds. So this is the second cluster that we've built this morning. Again, if we look at the CPU, that'll give us an indication of how long it's been ready. I'll just go back a little bit longer, go back to 2 hours. So we can see that it came online at 18 minutes past 9. So I kicked it off at 8:45. So it would have been about 35 minutes before that came on. So moving back to the presentation, the third way, luckily enough, is a video. So as I said, Sylvain, who's done lots of work for me, for all of us really, from Montpellier in client engineering, he's got like a 17 minutes, so it's edited because obviously it takes over an hour to do real time, but he's edited to cut it down. And this shows you how to actually perform a single node OpenShift installation via the Red Hat assisted installation, which is via the GUI or browser based from the Red Hat site as well. So that's the third way of doing it. And I think I'm just about going to run out of time, 10:30. How's that? So with that, Paul, I'll hand back to you.
Thanks very much, Paul. That is brilliant, right? So Paul told me that he'd got 2 ways of doing this, maybe 3. Each took 45 minutes to an hour, and we had to put it into 30 minutes. So brilliant. So thanks very much, Paul. Just one question, very quickly. You did all this in TechZone? How did you do it?
Right. Okay. So originally, I pulled up in TechZone. We have for the application modernization where we deployed the SOC shop. We've been doing that for 2 or 3 years now. There's an environment for a standard OpenShift, which is 3 control planes. Oh no, sorry, that's actually on a single node. It's just not the officially supported one. So I did it on that, but the DNS was set up slightly different. So I've worked with TechZone to create a new environment specifically for Snow. So we just have the 2. Good if I show you.
This is a bit like David Attenborough, Life on Earth, at the end, and they said this is how we did it.
Yeah, exactly.
This is how we did what we showed you.
Let me show you here. So this is in. So I've set it up as Snow 2 Ansible. But if I go to my created collections, so in the past I've obviously created a .NET Life one and application modernization one. So I've worked with TechZone to create this one. But this is what you get. You get 2 LPARs, one for the Bastion, one for the master. And the important thing about it is that all that network in the DNS is set up correctly for it. Yeah.
Okay. Brilliant.